Hello everyone! Here, we present a new tutorial for the brand new AI board from System Electronics, Astrial. In this tutorial, we present how to use a super complete sensor and LED matrix hat coming from Raspberry Pi ecosystem, the Sense Hat. This example helps you understand that Astrial is fully compatible with all the open hardware from Raspberry Pi ecosystem. Okay, let's get the hands on the Sense Hat. And let's find out how exciting it is to connect all types of open hardware to Astrial. The list of material used in this project is quite short. We just need our Astrial board, the Raspberry Pi CM4 carrier, and the Sense Hat. Connect the Sense Hat to the GPIO header of the CM4 board. Since the Sense Hat occupy all GPIO pins, you will need to power the Astrial board via the 5 volts and ground pins on the USB header of the CM4 carrier, as illustrated in the schematic. Here comes the software part. Once the hardware is connected, proceed with this configuration. To enable the Sense Hat functionalities, you must upload a custom device tree to your Astrial board. This DTB configuration is compulsory to activate the specific GPIO and I2C functionalities required by the Sense Hat. You can find the custom DTB in the resources folder of this tutorial's repository. If you are not sure of how to use a custom DTB, please refer to our GitHub guide. First of all, download and copy the tutorial repository via SCP to the Astrial board. Then install RTMU-lib. The Sense Hat includes an IMU, Inertial Measurement Unit Sensor Suite, for which you need this library. Download the RTMU-lib on your host device and copy it to your Astrial. Then be sure you have copied the right DTB into the boot folder. After that, go inside RTMU-lib and build the library. To run the setup script, you must run Python 3 setup.py build. After that, to complete installation, you must run the install script prompting Python 3 setup.py install. Now you can reboot because we changed the DTB. Reconnect to your Astrial. Now go to the Sense Hat folder and install Python packages. The SMBUS-I2 library is required for I2C communication. Install it using the following command: pip3 install sembus2 = 0.4.3. Now, you can run the first example with Python 3 Sense Hat example.py. As you can try, you can see the hello world running on the LED matrix. Now, if you want to run the IMU example, you will get an error. To figure it out, you must change the rtmu-lib.ini and select the I2C bus for the EMU, number 4. Using this change, configuration is fixed. If you try to move and rotate the board, you will get pitch, roll, and yaw values in real time, as you can see. On the GitHub repository, you can find other examples. An interesting example is the joystick example. Running this script, you can see directly on the LED matrix the direction of the joystick you choose. Each direction are mapped with an alphabet's letter. If you push down the joystick, you will get the letter D for down. Or if you push up the joystick, you will get the U for up. The same for right, R, and left, L. Pay attention that if you push the joystick like a button in the middle, you will get M as middle. You will get M as middle.